Hi, and welcome to episode 4 of the UILCS written series, where we are going to cover the material for question 4, which is strings. Question 4 is all about string methods. So before we talk about the string methods, we should probably start off and just like reintroduce what a string is. If you watched the data types video, you already know what it is, but we can go over it here. So a string is essentially a sequence of characters. So I guess we should start that by explaining what a character is. So a character is like one letter, one digit, just one of something. So this is a character, H. This is a character, 0. You can have an empty character, or let's say this is a space. But if I try to do something like HI and make that character, Java would crash out on you. Because a character can only be like one thing. Okay? And characters, also if you notice, they use single quotes. So a string, on the other hand, when I say it's a sequence of characters, what that means is, well, it's a sequence of characters. You could have HI, all these characters, you can write it in one string. So this is a sequence of characters. Right, and notice we use double quotes for a string. You can't make a character with double quotes, so that's illegal. And you can't make a string with single quotes. So how do you actually make a string? There's two ways. So the first way is by writing string, and then you write the name of your string. So let's just say S, that's 9S, is equal to, and then you'd write what's called a string literal. So let's just say it'll be like text. You basically enclose text in like two double quotes. And this whole thing we call a string literal in Java. So if I refer to like something, I say it's a string literal, I'm referring to this idea, like text, whatever, wrapped in the double quotes. So this is one way of making a string, but the other way you can do it is like this. When you get back here, you can do string, and we'll call it S again, is equal to new string, and then here in the parentheses you would put your text. You'd put your string literal in here. So the reason you can write a string like this is because of object-oriented programming, which we'll discuss in a later section. And I'm just showing you this way, but don't actually write your strings like this. It'll work, but Java and UILCS writes their strings like this. Okay, so this is the way we're going to do it, and I can actually show you in code that both of these ways work. So let's say I was writing string hello world is equal to, I could also write string hello world equal to new string, and here I'll write hello world. And you can see there's a orange squiggly line because Java is saying new string is redundant. Java literally wants you to write it, or IntelliJ wants you to write it as the string literal, the first way. But if we were to just print out hello world, and then another line, print out hello world, you'll see that we get the same thing. The output, oh, I forgot to put a freaking, okay. Let's add that exclamation point in, and you'll see, yeah, the output is the same. So both ways work, but choose this one. Okay, so let me just clear all that. Okay, so let's talk about methods you can do on a string. That's primarily what you're going to be tested on. They pretty much know how to use a string. So it'll be like they'll give you a string and it'll apply some string methods on it, and you're going to have to say what it does. So the first method, or here, as I talked about earlier, I said how a string, like let's say hello world, it's just a series of characters, right? Or a sequence of characters. Well, what if I want to grab an individual character? How would you do that in Java? Like, what if I had a string s is equal to hello world, and I wanted to just look at the h car? What if I want to focus on this character in particular? Well, Java has a method for this, and it's called the car at method. So this is the syntax. So car at, and then you'll pass in an integer index. So as the parameter, you'll pass in an index. So what does this look like? With this hello world example, if we did s dot car at, and we pass in the index of h, which is 0, this would return h. And now it returns it as a character. So I can show you this in action right now. If I look at the string hello world, and let's say I want car h, I want to get the h character from here. I'll do like this for now. I want to get the w character from this, and I want that exclamation. And actually can't say that. So I'll just do, I want the d character from this. So I can do what? I'll do hello world dot. So whenever you're calling a method of a string, you're gonna put that string name, whatever it's called, then do a dot, and then type in your method. So we're gonna do car at and index 0. Note that index stuff is just saying what type you're allowed to pass in here. So it's saying that whatever parameter you're passing in here has to be an integer. If I try to pass in 0.0, we're going to get an error because Java is expecting you to give an integer, not a double, right? Int index. It's just saying whatever you're going to put in here, like whatever number, whatever parameter you're putting in has to be an integer. Anyway, so we know h is the 0th index. Then we can do the same thing. We can take the car at 0, 1, 2, 3, 4, 5, 6. Remember that spaces count as characters, so you have to factor that in. And then lastly, D is going to be car at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see that we're not getting any compiler errors because it's returning a car. If you look at this, right, click on it. Yeah, right here. It says the return type is a char. Okay? Or car, however you pronounce it, I guess. But yeah, so if we were to print these out, you'll see that we got those values. We got H, we got W, we got D, we got the individual character at those index. So that is the car at, char at, however you say it, method. Okay, so now we're going to talk about a string equality. And there's a few methods we're going to go over with equality. So let's say you have string s is equal to, I don't know, like hi. And then string s2 is equal to hi with an exclamation point. And you wanted to check if these two strings are equal. Well, you can do that in Java with a method called dot equals. So you could do, actually no, let's do the example string s is high and then string s2 is high, like this, with a capital H. So if you want to check if these two strings are equal, we can use the equals method. So it will be equals, and you'll pass in a string, and I'll just say S O, or I'll say S2. Okay, and so what this will do is, if string S is equal to string 2, if they're the same, it'll return true. If they're not the same, it will return false. So if we were to run this example, so we run s dot equals s dot equals, and I'll just pass in s2, we are actually going to get false. And you remember saying, Sid, they both say hi. How is it that they're not the same thing? Well, because Java views lowercase characters and uppercase characters as different characters. So if you're saying, Sid, that's kind of stupid, is there a way to make Java not care about or ignore case? Well, there is. It's the dot equals, so equals ignore case method. So what this does is it takes whatever, it's the exact same thing as the equals method, but it doesn't look at but it doesn't factor in case differences. Okay, it treats pretty much capital H is equal to lowercase h. Wait, it ignores case. So if we were to run s dot equals, and I'll just do it in black, s2, well, the compiler will say, and that'll be returned as true. It's kind of wrong as the compiler will say because there's no errors. But, excuse me, this will return true because the only difference is a case difference. That's lowercase, that's uppercase. Excuse me. But since this function ignores the case, it treats lowercase and uppercase as the same. But if this one had like an exclamation point and this one didn't, for instance, then you're going to get false. Because now they are different strings. That's high, no exclamation, that's high with an exclamation. Alright, so let's keep going. And the next method we're going to talk about is the starts with. So this is another equality method. So let's say you have a string. I'm just going to do it all black. String s is equal to pickle or something. I don't know. So let's say we had a string of pickle. And let's say you wanted to check that this started with a capital P. I don't know, you're writing some code and it's like every pickle must start with a capital P or something. Well, there's a method to check what a string starts with. So that's going to be the starts with method. So you can write starts with, and then you'll put in your string for your starting string. Okay, starting str. You might be asking, Sid, why is it a string and not a character? Because if I'm just looking for a pickle, if I'm just checking to see if it starts with capital P, that could very easily be a character. Like you could have a character like this, or a string like this, like I don't get it. Why does it define string and not character? Well, that's because you could actually check and see if it starts with, instead of just pickle, you could check if it starts with pick. That is not even black at all. I don't even know why I thought black would be there. It's the first thing. You could check if the string starts with pick, or you could check if the string starts with pie or pick, or I guess that's a bad example, or pickle without the E, you know? You can check to see if the string starts with a sequence of characters or a string. So if we were to check this with our method, we do s dot starts with, and then we would we check the string, so double capitals P. So what would this return? This would return true, because a string does start with a capital P. However, if we replace this with a lowercase p, then we will return false, because the string starts with a capital P and not a lowercase p. Okay? Now there's a second type of starts with that you can also call, and that starts with your string, and I'll just say start, but you can also have an index. And what does this index do? Well, it tells Java where to start searching. So, or where to start. So remember, index are 0, 1, 2, 3, 4, 5. So if we put in an index of 3, Java would start here and then check to see if your string that whatever you passed in correlates with this. So if I passed in s dot starts with k, lowercase k, at an index of 3, let's make sure that's right. Yeah, this will return true. So Java would go to the third index position, see, hey, is this string start with this k? And it'll be like, yes, it does. So it's cool. We could do KL. Starts at 3. Is KL, I guess, the first two characters in this string sequence that we're looking at right here? And it'd be like, yes. Okay. I think it's pretty self-explanatory. The only thing you need to know with this index is that like that's where it doesn't like when you pass in tree, it doesn't like skip over tree and it starts looking here. It includes, typically your starting index is always included. Okay, so that's the starts with method. Now, there's two more for this equality. Just as there's a starts with, there's an ends with. So you can do ends with string and string. So what this will do is it'll check if your string ends with this thing. This is the exact same idea it starts with, checks the end. So if I did s dot ends with, if I did s dot ends with e, this would return true because s dot ends with, or the pickle ends with e. Now, however, there's no ends with index, that doesn't exist. So you can only do ends with. Now, it doesn't mean you can't do ends with LE or something. You can do that, and Java will recognize, hey, this is string end in LE, and it does end in LE, so it's good. Okay, so that's what I'm just, exact same idea starts with, but there's no index, there's none of this. This doesn't exist for ends with, and it just starts at the end, not the beginning. Okay, that starts with and ends with. They're pretty like self-explanatory, I'd say. Just remember that your starts with can also start with an index. Now this next one is not very self-explanatory, and it's the compared to method. So compared to, and the way is basically, and you'll pass in another string, so I'll say string s2. and this returns an integer. So we need some background before we jump into this. So there's a concept, not only in Java but in general, called the ASCII table. Okay. I don't know why I wrote the I's like that, it's written like this. It's the ASCII table. Because remember that computers, they don't really understand that A means A, you know? There's no correlation. The computer sees A's and all your letters and characters as numbers. So the ASCII table is a representation of what character matches with what number. A, capital A, is 65. Capital A is 65 in the ASCII table. Lowercase a is 97 in the ASCII table. Make sure I'm right. Yeah, okay, cool. So I don't want to be giving you misinformation. 0 is 48 in the ASCII table. And then 1, and by 0 I mean like the character A, the character lowercase a, the character 0, not the number 0, the character 0. Space is, let me see if I can find space. Oh, space is 32 in the ASCII table. Okay. Oh, sorry, space. Yeah, space is 32. I'm right. So these are just some possible values, right? So what the compare to method does is it'll take two strings. So like you pass in a string, right, s dot, and you have another string. And it'll look. So let's say we had one string, and hold up. Just give myself some more room. Okay. So let's say I had a string. I'm not gonna write all that. I'm just gonna write down what the string is. Okay, so the room. So S is, let's say, A, B, C, D, E, F. And then S2 is A, B, C, D, E, F. So very similar but different strings, right? Now let me write that in blue. Okay, so what the compare to method does is it basically looks at each of the characters and compares their ASCII value. So it'll take the first string, right? Take its ASCII value and then subtract it. So this is lowercase a, so it's going to be 97. And subtract it by the ASCII value of the second string. So that'll be 97 too, and you'll get 0. When you get 0, it keeps on going. So we'll go back and it'll check now the next set of characters. So we'll check B, which is 98. And it'll check and subtract that from B of S2, which is also 98. So you'll get 0. You'll move on to C, it'll check this. It'll give you the ASCII value of this, which is 99. Check that with the other one, you're going to get 0 again. Then it'll go to D, and it'll check D, and it'll see, hey, wait a minute, that's 100, but that is what? 68. And that'll give return a positive 32. And then, because of that 0, whatever that value is what's going to get returned. So 32 is going to be returned. So we have to like explain that a little bit more. A, B, C, D, E, F. And then we're looking at A, B, C, D, E, F. The compare to method starts at index 0 and gets the character remember we talked about a char at method, right? It gets the character of both strings at index 0 and then kind of subtracts them together. It'll subtract the ASCII value of S1 and now say index 0 minus the ASCII of S2 at index 0. So if this is 0, it's going to move the index to 1 and repeat the process. But if it's anything but 0, that's going to be returned. Okay. And let's talk about some specific cases. So if S1 is A, B, C, D, E, F, G, and then S2 is just A. Well, you might be wondering what it's going to return. It's going to get the length of both strings. So this one will have a length of 7. This one will have a length of 1. It'll subtract the length and it'll return that. So you're going to get 6 back. Okay? And I think I don't remember any other edge cases. So hopefully I think that's the only other one you could see for your LCS as an edge case. Everything else just your ASCII table, I feel like. Okay. Are there any other methods? No, that's it for the equality section or comparison. These are all the ways you can compare strings. And obviously there's more, but they're not important right now. These are the ways on question 4 at least you'll see. Okay. So let's actually dive into these in some code. So first we'll look at, let's just say string s1 is equal to hello there, my good sir. String s2 is equal to hello there, my good pal. We could run, now print it out, s1 dot equals s2. And you'll see this will be false because they don't equal each other. If I made this sir instead of pal, it'd say true because they do equal each other. If I made this hello there my good sir with a capital S, it'd be false because now remember we're using the normal equals, and equals pays attention to case differences. But if you want that case difference to be ignored, then you can do ignore case. And now when I run that, we'll get true. Let's reverse this to pal. And then of course you can check starts with. So we'll run starts with H. And we run this, will get true because it does start with H. If I tried lowercase h, it would be false because this starts with a capital H. And there's no ignore case method for starts with. Now you can also check at what index from 0. Like if we're starting on index 4, what's the start with the index 4? So 0, 1, 2, 3, 4 is this, right? So it would start with O. So if we ran this, we would get true. If I ran there, my good sir, this would also be true. But if I tried to run oh there, or just some random thing, right? It'd be false. So it's just the same as starts with, except we're shifting where we start with. Normally you start here on index 0, but if you pass it an index, it'll start there at whatever index you pass with. Okay? And just like how this starts with, there's an ends with. Ends with. So you check ends with sir or ends with R. Let's run. This would be true. Ends with sir. This would be true. Right? Ends with capital sir. This would be false. And there's no ends with ignore case. You can see even if I try and type it, Java's confused. There's no ends with ignore case. And there's also no ends with offset. There's no offset for ends with. Yeah, you're expecting one argument, but it's getting two. Okay? Or sorry, there's no index what ends with. It's only like this. And of course this sorry, this compares to. You can do S1 that compares S2. And so return 3. So all of this it says is true, but then when you look at and I can print out right here S minus P in the ASCII table, you get 3. And I can also just tell you that via the table. S lowercase s is an index 73. This is the same thing as running 73 minus 70, which would be 3. If I did S2 that compares S1, we will get negative 3 because now, and ignore the second expression, because now it's going to be 70 of the P minus 73 of the S. When we did S1 dot compare to S2, we're telling Java, look at S1's character and minus that by S2's character. But now that we're looking at S2 dot compare to S1, we're telling Java, look at S2's character and minus that by S1's character. And you can also see that length difference we're talking about. So I'll just simplify this. I'll say ABC, and this one is ABCD. When I print this out, we're going to get a length of 1. And I think that's true for both of them. Oh no, it's negative 1. So, oh yeah, so when it has nothing, when it can't go off with characters, when one string is longer than the other one, in this case, it'll just compare the lengths. So it'll be if it's S1 dot compare to S2, it'll be S1 length minus S2 length. And if it's S2 dot compare to S1, it'll be S1, it'll be S2 length minus S1 length. Right? This is always first. And you also saw that it was compared to ignore case. I didn't cover that, but if I had ABC and I had like this ABC and I ran this, we're gonna get 0, right? Because it's ignoring case, so it's gonna view these as the same. Even though they're different ASCII values, it's gonna treat them as the same, essentially. Okay. So those are the equality methods, but we're not done. We still have more methods to talk about. So let's just, and actually let me be smart about this. Let's move over to the next set of methods. So these are going to be searching methods. So if I had a string, and I know we call a string s, and we say that's equal to hello. Or let's make it hi there. First example. Hi there. And I wanted to confirm that this there existed in the string. I could do a starts with, and then factor in that offset, right? But in many cases, what if I didn't know if there was in the string? What if I'm just trying to guess and see if it's there? Well, Java has a method called the contains method, and it's like this. So it'll be contains and then inside the parentheses, you'll pass in your string. Okay, for this instance, if we're looking for there, we would do s dot contains, and then we pass in the substring we're looking for there, and then if there exists in the string, it'll return true. So in this case, it'll return true. But let's say we're looking for capital T there. This will return false because that sequence of characters, this capital T HERE doesn't exist. It doesn't matter that these all exist because we're telling Java, see if this whole sequence, if this whole capital T HERE exists in string S. Okay? That's the contains method and it's pretty useful. Now, we talked about the car add method, which is if you pass it a string like this, for instance, it'll tell you which character is at that index, right? Well, there's kind of a way to reverse this called the index of method. So if I was looking at the example from above, hi there, and I wanted to get the index of t, we use the index of method, which is like this, index of, and it'll take in your car or character. I'm not gonna write all that, I'm just gonna write character. So you know your single string letter character, okay? So if we were to test this, we do s dot index of, let's say we're looking for the index of I. Or no, let's say we're looking for the index of h, and it's a character, so single strings. Java will return 0 because we'll look for h, boom, finds it right there. Okay, what index is that? That's 0. Boom, bada bing. What if you wanted Java to find this h instead? Like you have multiple h's, you want to tell Java, give me that h. Well, you can specify a start index. So there's a form like this. Index of your character and then your index as an integer index. Okay, so what this will do is pretty much whatever index you pass in, that's where Java's gonna start from that index and it'll look for the first instance of that character. So if I had the string hi, Hill, Billy, Bob or something, I don't know, Bob Hooligan, and I was passing this in as a string, right? Let's say it's some string, say it's string s. Well, you could run s.index of h, and this would return you 0. Or you could specify, and whoa, this is to be a car, so it should be like this. So you could run this and it'll give you 0. You could specify an index. Let's say let's start out 1. If we're starting at index 1 now, instead of 0, it's going to start here, find the first instance, so that's going to be 1, 2, 3, and it's going to return 3. Now let's say we're starting at 4. That's going to be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that returns 17. Because now we're looking at 4, it's going to start here and find the first instance of h, which you'll find as 17. Let me just make sure I'm right about this. If you did s1 dot index of yeah, I'm right. Okay, cool. Okay, so now you can also go backwards. I told you how index of finds the first instance. Well, there's a method called last index of. This does the same thing as index of, but it starts from the end of the string and then goes back. So it has the same methods and stuff. So let's use the first form, which says you pass in a character. Well, let's say I passed in, this is kind of getting a bit confusing. There's a lot of stuff going on over here. Okay, not anymore. And let's look at last index of, which is new string I'm going to make. Like string s is equal to hello there, okay? And then we just wanted to see last index of, where did it go? Oh, why am I all the way up here? So let's say we want to get the last index of e. So we would write last index of, we pass in the character e, and it'll return the last index of finds of e. So what? This is 0, 1, 2, 3, 4. Let me make that a little bit better. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Java will return 10 because that's the last index it found of E. Now Java doesn't actually start from the beginning and work its way around. No, Java will start from the end and then go back. Because if you're looking for the last index, it's a lot more efficient to start at the end of the string than work at the start. You know what I mean? So Java starts at the end. So really what Java is doing here is it's starting at the end of the string here. It's looking for the first index of E, which it finds at index 10, and it returns that index. So if I were to specify an index like you saw that we did with the other method, you can do it for this one, like I said, 7 or something. Well, Java is not going to go 0, 1, 2, 3, 4, 5, 6, 7, and then go like this. Java's not going to do that. Java is going to go 10, 9, 8, 7, wait, 10, 9, 8, sorry, 10, 9, 8, 7, because we conclude the starting index. It's going to start here and it's going to start looking back for E, which you'll find on index 1. So this should return 1. And let me test it right now so I can prove my claim because this seems a little bit sketch. Hello there. And then let's just do s south s dot last index of E from 7. Boom. Okay, good. I'm right. See? Because Java starts at, it counts backwards. So it's not going to go 0, 1, 2, 3, 4, 5, 6, 7, and starts here, and then we will turn 8, and then we'll turn like 10, and we'll do that. It'll start, it'll go 10, 9, 8, 7, and then find the first index of E it finds. Okay, so that's last index of E. That's the last index method. And it kind of makes sense. Why? Because If Java were to do 0, 1, 2, 3, 4, 5, 6, 7, start here and go to the end, well, it's always going to return the same thing. It's also going to return the last index. There's not going to be a need for this. What from index really means here is kind of like a wall. It's like, okay, 7. So only look for, find me the last index E from this section of string. If I put a like E instead of this white space, we're gonna get a different answer because now that's 5. That's the last index. Okay, it's saying the index you define. Look at the string up to and including that index, and find me the E. Find me the last instance of the character E. Okay, that is last index of, and that's gonna be it for searching. That's really it. Just know contains. And let's actually go over the other ones now. Now that we've reached the end, I normally like to go over them at the end bit over here. So we could run a few lines. We have this one, but we also have a generic last index of. So like this. So if you run that, you're just gonna get what, 10? Yeah, exactly. Boom, bada ping. You could run start index, or no, index of, and it's return you one. It's kind of funny how these two statements return the same thing, because index of looks for the first index of E it'll find, which is right here. But you can specify start me at like 9 or something. And then it'll start you over here at index 9, because 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Start here, and it'll find the first instance of E, which is at index 10. Right? Now you could also do so s dot contains hello. So you're trying to see if this sequence of characters, if it's in the string s, and it is, so this will return true. But if I make this lowercase h, well, now it's going to be false, and there's no contains ignore case. If I try and write it, you'll see it doesn't exist. We're not getting that blue highlight, it's not real. But yeah, you see contains with a lowercase h is going to return false, because even though ELLO, even though that's in here, that's right there, we're asking Java, find me this specific sequence of characters. Find me lowercase h, lowercase e, lowercase l, lowercase lo. Find that in this string. If I just asked for lo or something, this will return true because lo exists. And there's like no second index or something. It's just one index. If we look at how do I access this? Yeah, if you look here, you'll see that it's only asking for one parameter. And don't worry about what a char sequence is. Just for now, if I say string, just put in string. Don't worry about it. I think that's a little bit. I mean, we might get into that in the next 25 when we get over there in object-oriented HGens. Well, a little bit past object-oriented programming. Okay. Now we're going to talk about extracting stuff from a string. So if I'm looking at the string, and let me just clean up the string because the Loki looks kind of chopped right now. If I'm looking at the string, hello there, and I'm asked, let's say you want to just get this sequence of characters and you want to make that its own string. Like you want string s2 to just be hello. And just to help, I write down the indexes. So in this case, you would want, for hello, you're saying I only want the characters from index 0 to index 5, not including the 5th index. Well, you can do that with the substring method. So the substring method is like this. It's a substring, all lowercase, substring, and it'll have an int for your starting index, and you'll pass in an int for your ending index as well. Okay, so what would this look like if I was trying to get hello, and this will return the string it finds there. So if I did s.substring 0, 4, now you might say Sid, well, this will return hello, right? Because, I can't draw for the life of me. Okay, because you literally just said hello is contained 0, 1, 2, 3, 4. Those are the indexes. Like, that's it. If we're getting the string starting at index 0 and going to index 4, that should be hello, right? Well, actually, it wouldn't be hello, it would be hell, but it's because in Java, this last index, your end index is always like excluded. You know how in every other example, your starting index was included? Conversely, in every parameter that has an end index, it's excluded. Now, I don't know if there's like a catch-all truth here, but for all the times I've seen it, it's been true. So yeah, your end index will be excluded. So if I actually want a hello, we have to go from 0 to 5. Because now the fifth index, which is space, will be excluded, and it'll return hello. Now, there's another form of substring where you only pass in a start index. And so what this one does is, it looks like this. Int start. What this method does, it'll go from whatever starting index you defined, and they'll just give you the rest of the string. So start at start index and then give you that plus the rest of the string. So if I did s.substring 2 or something, right? It's passing a 2. It's going to go 0, 1, 2. And remember that that L is included because start index are always included, and it will return LLO space TERE. There. Okay? Because what this basically means is you're telling Java, when you're passing in just your one index for start here, and then just go until you reach the end of the string. So those are the two forms of substring. And now there's also split. And so what split does is, let's say you have a list. And actually, no split. Okay, make sure you know this, because split is low-key goated on the programming section. I don't know if we're going to cover programming in this course, the programming section. I'm really just focusing on the written section. I feel like also if you know everything there, you should be good for programming. I mean, maybe dynamic programming you might have to know. Anyways, so let's say, what are we on? We're on split, yeah. You have a string A, comma B. Or let's say A, line B, line C, line D, line E. And you wanted to make a list or an array containing all these letters. So you want it to be something like this. A, comma, B, comma, C, D, E, like this, right? So almost as if we're splitting the string into a list, separating it or splitting it by the sign. Well, there's a method in Java called the split method. Split, where you pass in a string and let's call it a delimiter for now. And what this will do is it'll split the string into a list or into an array based off that delimiter. So if our delimiter was this, if we did s dot split by that straight line sign, you'd get this as your output. So the second way you can write split is with a limit, right? As we, I think I wrote up here, I'll write again. S dot split with your string, now let's write like this, and then your limit. Whatever, you pass in a string, and then you pass in your limit. And so what limit does is basically caps off the length of your array. So if I were here and I was doing s dot, I'll say this is s dot split, and I'll pass in this, and I'll say 4. What this basically does, it'll split normal, so you'll have a split by the like straight line, b that'll be split by the straight line as it should be, c split by the straight line, but then d straight line e are all going to be 1 because you're basically saying or like Java's understanding, hey, wait a minute, we're approaching that length 4. We're 1 away from 4. And if we're trying to split this whole string into a list, basically once we're at this, or this is a better way for me to describe it. So if we're looking at length, when Java's here, right, it can figure out, hey, wait, we're 1 away from reaching that limit. So I'm just going to take whatever's left in the string that hasn't been split yet. I'm just going to put it all into one section, one string sequence. Just how we ended up with this, okay? That split with limit. Just kind of view it, if you view it in that length way, it'll make more sense. View it as you're splitting the string normally, but when you're one below your length, when you're 1 below 4, or 1 before your limit, sorry, that's what I should say. So you're splitting your string normally, but when you're at 3 and your limit is 4, right, starting at 1, then take whatever's left and put it as your last thing. That's how it's doing here. I'm saying length because we're referring to like the length of a string, which is why we're starting the length of your list, which is why we're starting at 1, because length starts at 1. I've been talking a lot about length and I haven't really described it yet. But those are all the ones for extracting stuff out of a string, so let's do some testing right now. So I think first we should start off with the split. So here I have the same situation. Now you may be asking Sid, what the flop is going on here? So this is because I've been calling it a string is what we're passing in. Technically it's a regular expression. And we're gonna have a section on regular expressions because they get tested on the written exam, but that's the next 25. You're not gonna be tested on them in the first 15. So don't worry about this. For simplicity's sake, why is there just, oh, I'm gonna go here and I'll make these spaces. Or I know, I'll make them stars. Hopefully it's not a star, regex. Or regex is how I've heard people say it. There's no universe right now. Let's do this one. I'm sure this one's not regex. Yippee! Let's run that. You're gonna get A, B, C, D, E. As normal, let's say limit it to only 3 elements in my list. Right now we're going to be limited to only 3 elements in your list. A split normally, B split normally. But because we're saying limit my list to only have, or we're limiting the array to 3, elements. So then Java's gonna be like, hey, wait a minute. I'm just gonna take everything else and dump it in here. So that way I can split the string into 3 elements following this regex. So if that makes sense, if it doesn't, let me know in the comments. I will explain it a little bit better. And let's talk about, or here, I'll explain it one more time. This limit is basically the length of your array that is outputted by a stud split. So if we're defining a limit of 3, we're telling Java, make sure that my array only has 3 elements in here, only has a length of 3. So as you can see, we only have 3 elements because it'll split normally for the first 2, but when Java realizes, hey, I'm 1 away from my limit, then it'll just combine whatever left of the string and push it all in here. So it split A normally, and it killed this guy. It split B normally, and it killed this guy. But then when it got to C, it's like, and it got to all this, it's like, hey, wait a minute, I gotta just dump it all as 1 element. Because if I were to split C normally, and make the list like this, well, the only way we could include all the other elements, even if we wrote it like this, would be going over our limit and going to 4. So we can't do that. So Java just does this and calls it a day. So the way I see it is just like when we're 1 away from that limit, it's perfectly normal up till the point where we reach that last element. And it'll just, for that last element, it'll just combine everything left into the last element. So let's also go over substring. Substring is pretty important. Make sure you know how it works. Let's stop substring. I'll do A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. It's just some random letters. So substring works like this. Well, we already talked about it. You can split a string from a beginning index up to, but not including the last index. So it's going to be 0, 1, 2, 3, 4, 5, but it won't include 5, so we're going to get A, B, C, D, E. Or you can split it from the start index. And I was wondering why I'm doing this, because this is literally the full string. If I could do 1 or something, and then that A would be gone. Right? It'd start off at index 1, print index 1 to the end. I could start at index like 15 or something. Right, you start at index 15 and you go to the end. Okay. So those are the extraction slash substring methods. And now we're going to talk about the transformation methods in Java. I will fit all of them in one video. We may be at an hour. There's still a lot more, guys. I'm so cooked. Alright, so now we're going to talk about transformation. Transformation is pretty easy. So let's start. Let's say I have a string s is equal to ABC. Let's say I want to make that all uppercase, or make that 2 uppercase, if one could say. Well, you would use the 2 upper. No, you know, even though I'm like lazy with colors, I'll at least have the method signatures in the right color in blue. So 2, why did that just disappear when I 2 upper case, and it's written just like this. Upper and case are defined as separate words. Okay. You pass this in. There's no parameters. I mean, there's one with parameters, but you're not going to be tested on that, so don't worry about it. So it's really straightforward. It'll take the string and return to you an uppercase version. Now, one thing I want to talk about with transformation stuff, it's not updating s. It's not taking this value of s like S right now is pointed to this ABC, it's not taking that and changing that to point at, not doing that. What it's doing is it's creating an ABC here and it's returning it to you. So you could make something like S2 and point it here. And there's conversely A2 lowercase. It's the exact same thing as 2 uppercase. So if I took the string, a capital ABC, let's say that was a string. And I did S dot 2 lowercase. It would return ABC. And okay, simple, right? And let's say I wanted to take S and uppercase it. I'm gonna run that and you're gonna maybe think it's gonna output a capital ABC. Well, it doesn't. It outputs lowercase ABC. And why is this? It's because strings are immutable, which means cannot be changed or mutated, right? So, to uppercase is a transformation. It's trying to mutate that string, trying to make ABC to ABC, but that's not impossible because strings are immutable. So what's actually happening is it's returning ABC to you, capital A, capital B, capital C, and it's your job to assign that to a new string. And if I were to call S2, well, now you'll see that S2 is capital. All right, so the next method to talk about is the strip method. So you write it out, it'll be like this. Yo, why is it like, hold up, it's being weird. Let's zoom in. Oh, let's zoom out. Okay, the strip method. So essentially what this method does is it'll strip away any white space from a string. So if I passed in a string, let's say I had a string, what S is ABC, well, let's say string S is, and we have a bunch of white space here, and then I have ABC. Well, if you run s.strip, okay, so just mirror these, okay, no, they're the same, yellow, or blue. If you run s.strip, you're gonna get that same string back, but all of this white space is gonna be removed like this. There's, and in addition with strip, there's strip leading, and then strip tailing. And they do the exact same thing, remove all white space and stuff. But it's just strip leading will remove. So if I had a string, bunch of white space ABC, and then let's say we have a bunch of white space like this, right? And this is our string. What strip leading will do is it'll remove all of this white space, so the leading or starting white space. What strip tailing will do is it'll remove all of the closing white space or ending white space. What generic strip does is basically it'll remove all white space. So stripper will remove all of this. Stripper leading will just remove this white space, and then strip tailing will just remove this white space. So I think it'd be best if I showed this to some code. Let's open up IntelliJ and then close out this. Anyways, so if I had a string s equal to ABC, just like in the example I showed, and then I printed out s dot strip, you'll see that we get ABC back, but look, if I highlight over it, there's no white space. Versus if I print it out, I can see the difference. If you print it out S, like this, you see how there's white space? If I highlight that line, you'll see there's a white space all here, and then white space all here, right? S.strip, it removed all of that white space. If I did strip leading, and we run that, well, you'll see that when I hover over this line, there's a bunch of white space following this string, right? Like it only stops hovering right here. And maybe asking Sid, I thought we just ran strip to the generic strip, which is supposed to remove all the white space from the start, from before and after the text. Well, you'd be right, but remember, strings are immutable. So what this is doing is, even though it's stripping white space and doing all that, it's not actually not changing the original string. Okay, it's not changing the original string. But all of these transform methods, they don't actually change the original string. Like, let me just run, I think I saw this with 2 uppercase, but if I did s dot 2 lowercase, right? And then I ran that. And then you'll see we'll get this, right? But then if I print it out as after, you'll see we get an uppercase. Because all of these methods that we're talking about, all of the transform methods don't change the original string. Because strings are mutable. Mutable slash non-changeable, I guess. Okay. But yeah, just to show. So you can see when we run strip, it strips everything from both the leading and trailing white space. When we do strip leading, it removes just the leading white space. And then when I do strip tailing, it removes the tailing white space. So yeah, as you can see here, with strip tailing, it just removed the trailing white space. So I still have all this leading, but then I can't hover past it anymore. There's no more white space. There's another method called trim. And trim is the exact same thing as strip, except there's no leading or trailing variants, okay? So trim is old. You don't use it anymore. It's depreciated, which means that Java's gonna remove it at some point. Strip is new. So they should be testing you on strip. They shouldn't be testing you on trim. If they do, I don't know, they're being stupid, I guess. Anyways, let's move on to replace. So what replace does is it replaces all of the cars of the string. So pretty much, okay. So now let's move on to replace. So this is the method replace. And it'll take in your char, your character, pretty much your old character that you want to be replaced, and then replace it with your new character. So char new. And there's another variant where you can pass in a string of an old string and then replace it with a string of a new string. So let's say I had a string like this. String s is equal to ABC space DEF, right? And then I want to make that DEF. I want to replace this DEF with, like, I don't know, say CDE. Well, I can use the replace method for that. So it'd be s dot replace. And let me stay consistent with my theming here. S dot replace. So you'd be your old string first. So ABC, comma, your new string, or sorry, your old string to be replaced, which in our example is DEF, because you want to replace DEF with CED, comma, the new string you want to replace it with, CDE. And it's important to remember again, because strings are immutable, even though it's kind of confusing because it says replace, it's not actually modifying string itself. This will returns a string that's like this. A, B, C, C, D, E. But in terms of S, it's still A, B, C, D, E, F, okay? And we can run the same thing with the car version. So using that same string from earlier, let's say I want to make every single, and let's say we replace this. So we would assign this to a new, let's say S is equal to this. And then, so now, here, for simplicity, I'll say string S2 is equal to this. So S2 holds A, B, C, C, D, E. And let's say I want to replace every C with a Z. So I want to make them Z's. Well, we can use the character version for that. So we'd write S2 dot replace. And then it would be, remember characters, we discussed this at the beginning, are single quotes. So it'd be C with Z, just like that. And then if I go here and let's practice this. String S is A, B, C, D, E, F. And then I want to replace DEF with CDE. Well, you'll see Java's giving us this, IntelliJ's telling us this result of string that replaces ignored. And because, remember, if I print out S, a string is immutable, so it's gonna still have A, B, C, D, E, F, even though it's ran. What this does is it returns a string of A, B, C, C, D, E. So if I set this to equal to string S2, and then we ran this, well, string S2 is going to be A, B, C, C, D, E, but the original string is going to be S, because strings are mutable, and I just want to keep highlighting this point, because it's very important when discussing strings. Okay, so we have A, B, C, D, E, F, right? And then what I want to do was, let's just print out the result of replacing every C with C. And what this will do is A, B, C, D, E. And you can use this in a print line. What this will do is print line will just run this, take the return, or any print, it'll run this, take the return, and print that out. Okay, so that is replaced in both of its forms. Oh, there's one more actually. This is a lot more, bro. Holy yap. So, but we're not really done with replace yet. Okay, so let's say, you know how with replace, replaced every instance of the string, right? So every single instance of old string old, got replaced with string new, right? In replace, let me zoom that a little bit too far there. And that's chopped to make that look better. So every single instance of string old got replaced with string new, right? Well, What if you didn't want that? What if you just wanted the first instance of the old string to be replaced? You can do this with replace first. So what replace first does, exact same syntax, string old, string new. What this will do is it'll replace the first instance of the old string with the new string. So let's test out with some code. If I have string s equals abcdef, right? And then I just want to say, I want to replace the first instance of C with D. And actually this won't work. I just want to show you right now we're getting an error because there is no character type. There's only a string type. So you have to do C, D, right? And actually it's kind of a bad string for this. Let's do hi there. So if I want to place the first instance of E with D, you can see we get hi der, whatever. But the second E doesn't get replaced because it only replaces the first. And again, this isn't actually modifying the original string, print that out. This is just returning like a new string with the first E replaced with D. Because strings are immutable. And we're gonna keep bringing it up every time until you don't forget it. It's in your brain permanently. So let's run this next method now, which is concat. So you know about string concatenation, right? Where you take string, it's in the data types video, string 1, and you can add it to string 2, right? And let's say we assign this to string s2. Well, you can do the exact same thing with concat. So the way concat works, your first string you'd pass in string 1, replace the plus. So it'd be concat string 2. And these don't have to be literal strings like I'm showing here, they could also be variables. So if I had a string, let's show this. So string s is going to be equal to I plus there, right? That's string s. String s2 is going to be equal to hi dot concat there. And then if we did s dot equals s2, you're going to see it's going to return true because they're the same string. Yep. And I'm just so you can do with variables too. Let's say I have, I don't know, string hi is equal to string there is equal to, you can make this hi plus there, or well, you probably need to define it beforehand. Yeah, like that. You have to define variables before you can use them. But that's pretty self-explanatory. Hi dot concat there. You'll see we're gonna get the same thing. It's gonna be true. You can use variables. That's all the point I'm trying to show there. So let's take a quick segment to talk about what the string pool is in Java. So the string pool is when you create a string literal, like this, right? And let's say I had another string literal. That was also like this. Well, Java's not gonna waste time making s point to some in the heap like hi, and then making s2 point to a different hi. No, Java has, because strings are used so much that this would become really inefficient and really just bad for storage overall. Java has this concept called string pool. So when you define a string literal, what that does is Java has this huge thing where it's going to call it the string pool. So when I run string s is equal to hi, it's going to take that hi and it's going to add it to the string pool. And it's going to make s point towards it. When I do s2, it's going to check and see if whatever string I put in here is in the string pool, which it is, and it's going to point s2 to that. But if string 2 wasn't, it just make its own instance in the string pool. So this was hi with 2 exclamation points or something, and a string pool right here. If this was hi with 2 exclamation points, Java would see, hey, there's no hi with 2 exclamation points, so let's add it to the string pool. It's like this. And Java does this when you're working with these literals. So whenever you're making a string literal, it'll add it to the string pool. Now, I remember I discussed earlier there's another way to make strings, right? You can do it like this. String s2, or we'll say string s3 is equal to new string hi. Now, when you write a string like this, with the new string method, what Java does internally is it'll make that point, that reference will point to the object hi like this. So whenever you make this new, think of it as, whenever you write this line, Java's creating a brand new hi. And place, okay, this is bad. Okay, so what if we had this line? String s3 is equal to new string hi. What Java does there is it pretty much makes s3 point to a memory location of hi. But then if I had another string, and let's just duplicate this for simplicity, string 4, yo, holy chopped writing. It said s4 is equal to hi. Java, when you write it like this, it makes s4 point to a brand new hi. It adds a new hi in the heap. So it looks something like this. S4, I mean, you can just kind of view it as like some empty space or like some space or something. S3 points to this instance, this hi, and then S4 points to this hi. So it's kind of weird because even though they're the exact same string, if you ran S3 equals S4 like this, you get false. Because when you use the equals equals, Java checks and sees if the strings are pointing towards the same memory location. But S3 is pointing towards this box and S4 is pointing towards this box, so this is not true. Which is why we say use equals equals. That's why we say use the equals method. Because if I ran s3 equals s dot equals s4, we get true. Because what this method does is it compares the individual characters of the sequence. It compares the two string sequences, or character sequences, h. It basically goes character by character. It compares h and h, and I, and exclamation, exclamation, and sees if this is a string. It does not check the memory address, it checks the content of the strings. Not every saying state is kind of stupid. What if I just wanted, why can't I just have it so that these two strings just go in like the string pool or something, and then S3 will become true, and then S4 will also become true. Why can't I just make it like S3 equals equals S4 by putting them into the string pool? And you can do that through the intern method. So what the intern method will do is if I add a dot intern right here, it'll take this S3 and instead of pointing it to a new instance, new like memory address for hi, it'll take that content, that hi that we added, and it'll add it into the string pool. So say this circles the string pool, here's hi, like this. Boom, 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 boom. And it'll make it so this points here. Now we would do the same thing for here, because remember string 4 still points here. If I copied this dot intern, or I'm not gonna do it, I'm just gonna write it over here. Dot intern. And well, correction, it was wrong for me to destroy that box. With the dot intern method, it'll just move it from instead of pointing towards this hi object, instead of pointing towards this hi, it'll point towards this hi in the string pool. And then Java has this process called garbage collection, where once everything is run, all your code is run, they'll see, hey, wait a minute, are there any data like this that's not being referenced by a variable? There's nothing pointing towards it, and it'll kill it. And it's actually, I want to segment a little bit. Why does it work like this? How come we're creating a new hi instance and then we're making S3 point to that, but then with the .intern method, we're making S3 point towards the string pool? Why can't I just make S3 point to string pool first? How does Java know to do this and then this? This is because of operator precedence. Remember earlier how I talked about how new and then your method chaining, your dot method, whatever, are on the same operand level. They're on the same level. And then when it's on the same level, Java uses associativity, and the associativity is left to right. So Java will run this, so we'll see, okay, they're on the same level. We'll start with this, we'll do this one first. So that's how we get this object, but then it'll do this, dot intern. So then what dot intern will do is it'll direct S3 to stop pointing here, and it'll make S3 point towards the string pool, and it'll add that hi to the string pool, okay? Sorry, if that was kind of confusing, just watch the operator presence video. So S4, if we did S4.intern, the same thing would happen. We would still have that hi in a box. It'd be waiting for garbage collection to come and kill it. But S4 now would point towards the string pool's version of hi. So it point here. And now these are both pointing towards the same thing. If you ran S3 equals S4, you would get true. And the reason I'm spending so much time on this weird intern method, you're like, Sid, I'm never gonna use this. I'm just gonna write if I want S3 equals S4, I'm just gonna write it with string literals. It's because on this year's invitational, they drew this method. They were talking about intern. Make sure you understand that, and we can test it in code here. Okay. That's not even close to spelling string. So here we have two string objects. So S1 is going to point towards string, but S2 is going to point towards a different string right now in the memory address. Even though the content is the same, they're pointing towards different instances of string. So if I were to print out S1 equals S2, I would get false, right? Because they're pointing towards different strings. Their pointers are not pointing to the same thing. These reference variables are pointing towards different objects. Okay, now let's do the same test, but let's not enter this. Well, now this is gonna segment. So Java's gonna stop pointing towards the string, and I don't know why I'm putting a freaking semicolon here. S1 will point instead to the string pool. I'll say this is the string pool, and the string pool will have hi. So what intern does is it takes this string, adds it to the string pool, and then makes that reference object point towards it. If we run this, we're still going to get false, and then we'll actually see this get deleted, but I'll keep it for now. It'll still be false because even though S1 points in the string pool, S2 points at that object string. So they're still not pointing at the same thing. If I dot intern this, what Java is going to do is it's going to abandon that, and it's going to have S2 point, I don't know how to sell this, bro. Like this. I don't know, something like this. S2 is going to point towards that string pool's instance, because intern will makes this string text. It'll kind of run how we talked about over in this example, right? It'll try and add string to the string pool. It'll see string already exists in the string pool, so it won't add it, and it'll just have S2 point towards that. But just like in that example of string literals. And if we run this now, we'll see that it says true. Because now S1 points towards the string pool, and S2 also points towards the string pool's version of string. That is the intern method. Make sure you know it. They test a lot on it. Or not a lot, but they tested on it. Alright. So next method we're going to talk about is the repeat method. So the syntax for that looks something like this. Repeat, that's so chopped. Repeat, and you pass in your int, and let's say amount. So what this does, it'll take a string. So let's say I have a string like, I don't know, ABC dot repeat like 4. And then what this does, it basically duplicates the string like 4 times. So what this method will return is this, a string of ABC, 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 ABC like this. And we can test this right now by going into the console. Actually, yeah, let's use this high. So I'll do s.repeat 5 times, run this, and you'll see I get 5 highs printed back. And I like to use this method like, because now sometimes you'll be asked, print out like a bunch of freaking equal signs or something. And if you know you need to print out 20 equal signs, then you can just do something like this. Put in your string equals dot repeat 20. And then you can just run this and then you'll get 20 equal signs. Right, the next method is the indent method, and it's pretty much in the name. So then you put in an int, which would be, I guess, the amount you want indented. And then so what this does is if I had a string of hello, I'll just do a string of hi. And then I did a dot indent 5. Well, it indents the string. Like when you write for ELA, in indent is pretty much you're taking this string, you're taking your text, and you're pushing it towards the right, right? That's how indents normally are. So pretty much what this method does is it'll put in like, it'll add in leading white space. So if I say hi with a amount of 5, it'll add 5 white space, and then it'll print out hi. So I can show this right now. Let's do s.indent 5. And then let's run this. And you'll see we have 1, 2, 3, 4, 5 white space. 5 white space before the text. Okay. Alright, for this next method, we're going to talk about something that are called escape sequences in Java. So, what is an escape sequence? Pretty much, let's say you're having some text, right? And you want hi to be on this line, and then there to be on this line. Like you want it to be on separate lines. Well, how do you do that in a string? Well, Java has this feature called escape sequence, where you do a /n, and then you'd write there. And Java, if I were to print this out, Java would print this out as hi, and then would print there out on a new line, just like this. And there are numerous amount of escape sequences. So when you write /n in a string, it tells Java to go to new line. You can do slash double quotes to tell Java, give me a double quote. Because you're asking why do you need that? Well, because most string literals are written with double quotes, right? And you put your text in here. So if I wanted the character, if I wanted double quotes to just be in my text, if I tried putting it normally, and I'll show it to you in code, it should probably be easier, right? If I wanted a string that looked something like this, he said hello, right? Well, if I try that, look what happens. He said hello, right? It's weird. Java breaks because Java will look at this quotation, think, okay, we're ending that string. Then look at this quotation, thinks we're starting a new string. So that's why you use this key. So Java understands what you're saying, like that. And now when I run this, you'll see we get he said hello. There's also one for tab, which just indents, like does the tab function on a keyboard. I think is the best way I can describe it. And there's a bunch more, but this question doesn't test you on escape sequences. That's not what it's testing you on. The reason why I'm bringing up escape sequences is because there's a method called translate, and here I can probably pull it up here. Hello dot translate escapes, yeah. And so what this method does is, if you give it text, it'll be able to say, oh, /n//n, that's the same thing as /n, which is a new line. It'll be able to say, oh, //t, that's the same thing as tab. I might be asking Sid, why were you yapping about //s? You told me escape sequences are one slash. Well, if you're writing if you're writing text to a file and you're trying to get that file in to your code, something you're going to be doing in the programming section, Java can't. If you're writing in some text file, let's say .txt, and you're writing hi/n bingo or something, well, Java doesn't really understand that this is a /n. So when you use this translate sequences or translate escapes, it is able to understand that, hey, this isn't some random text. This is a new line. We want it to be hi bingo. And I mean, I don't think you have to worry about this method because it talks about input and stuff, and I don't know if they're going to test you on that. Well, I have questions over input, which we'll get into later. But if for something that's like string specific, I don't think so. But I brought it up anyways because I don't know, it's on the list. This next one, though, they definitely could test you on this next one. And I'm not even gonna yap about this next one. It's the formatted method. So do you remember printf from the last video? This is literally the exact same concept. So when we did a printf statement, we had our formatted string here. So here's your formatted string, comma, your list of variables, right? We've talked about this before. This is a known concept. And if it's unknown, that's fine. Just check the last video. I'm running out of room here. So formatted works like this. You'll put your formatted string here. Dot formatted. And then you'll write your list of variables. Okay. So let's get back here and I'll just show that to you right now. If I did hi and I just put, I don't know, Jimmy or something. I'll do Jiminy. Well, we know what this prints, and I'll do it so that this is on a new line, on one line, right? And then if I were to do hi slash s dot formatted, and I passed in Jiminy, what is it? Rather than call, yeah, because it wants you to use printf form. It wants you to use printf. But for this example, it's going to write like this. Just say we get the exact same thing. Hi Jiminy. Boom. That's all the method does. We've talked about it before. Okay. So the next set of methods we're going to go over are the inspection methods. We're almost at the end, guys. 2 more sections left. Sorry this video could be so long. You might have to chunk it, low-key. But it's okay. You just need to know all of this anyways. So I understand if my teaching method is not the greatest for everyone. I'm not like some actual teacher or anything. I wouldn't even say I'm that good at it. If anything, you can use these videos just to show to you what you need to know. You know? Or you can get introduction here and you'll be like, hey, what's this guy yapping about, bro? Holy chopped yapping. Let me go ask someone else. But you know, at least you're learning then, you know what I mean? I feel like understanding what you need to know, even though they have a reference guide, I don't know, it's just not, it's kind of hard. Anyways, let's get back to it. So the next method is all about getting information about the string. So I've talked a little bit about getting the length of a string, right? So if I have a string hello and I want to get the length, well, the length is just how many characters are in the string. There's 1, 2, 3, 4, 5. So the length of the string length is 5. Now you can also use the length method. So if I did, and I'll show this to you in code, because it's just easier, you know. Hello dot length, you'll see that we're going to get 5. And I think it's important to point out that length starts at 1. Indexing, when you're looking at indexes, it's 0 based. When you're looking at printf, positional arguments, it's 1 based. And when you're looking at length, it's also 1 based. Okay? So, length method done. Let's move on to the next one, which is empty. And it's pretty self-explanatory. This one actually uses the length method. So what is empty does is it'll check the string, whatever string you call it on, and it'll check is length equal to 0. And if len is equal to 0, it will return true, else it will return false. So if I put an example in IntelliJ, right? I look at the string and I'm going to write is empty. Well, this is going to be false, and Java's probably saying, yeah, it's always false. Because well, this is clearly not empty, but you might be saying, Sid, what if I do this? Now it's going to say true because there's no characters in here. If I added a white space though, well, now it's going to be false because as empty looks at a white space as a character. Remember, as empty is only evaluating the length of the string, and if the length is 0, generally return true. If the length is not 0, it will return false. Well, a white space is a character. A white space contributes to the length of a string. Don't believe me if I take the string, the same one, and I call length, and I run it like this, you're going to get 1 back, so it's not 0. But if I use the isBlank method, isBlank does the same thing, so it will return true if your string is empty, or is just white space. If either of these conditions are met, you'll get a true result. Otherwise, you'll get a false. Okay? So let's show that right now. So if you see this one, if I ran is empty, it'd be false, right? On the contrary, if I did this exact same string and I ran is blank, this would be true. So false and true are your various outputs. Alright, let's move on to the next method, which is, okay, we can probably skip most of these. Okay, so for the next set of methods, before we talk about them, I'm going to introduce you to the idea of a factory method. So, and it's okay if you're unfamiliar with the idea of creating an object, because we haven't gone to object-oriented programming yet. When you're creating an object, the syntax is like this, right? So, class name, and I'm just gonna zoom in, bro. Yo, what the flop is going on with my mouse? Hello? Are we tweaking? Are we good? I guess we're good. So the syntax is class name, and then you write your name of whatever your object is, equals new class name. Holy chopped writing, bro. Okay. You know what? Because how it's gonna be. Right? Anyways, this is the syntax for creating an object. Now what a factory method does is it's a static method, which means you're calling it on the object, on the class name itself. But it's a way to create the object without using this new. So I would write class name O equals class name dot and then your factory method name. And what this will do is it will return the object, so it will return a new object. The reason you might use a factory method is because it allows for more flexibility when you're creating an object. Versus new does the same thing every time, we'll call a constructor. But with this factory methods, you can really have more flexibility and control over how your object is made. Anyway, so let's talk about some of these string methods. So string value of, and already your gears should be kind of turning, because I talked about how a factory method returns a type of the class, and this is a class string, so you notice it's going to return a string. So what it does is it'll take any like data type or any object or whatever, right? You pass in here, and it'll convert it into a string. And it can be anything. It has to be an object. I think I used data once, right? I'll use data again. Oh my goodness, if I could even fit it, bro. Data. And it'll just return a string representation of that. So string, I don't even know. String of data. Okay, what do I mean by that? Let's take a look at that encode. So if I had an int I is equal to 5, well, if I did, obviously I can't use true uppercase on this, right? I can't use any string methods here because it's not a string. I can't use .concat on an integer. What I could do is string .value of I, and this will turn into a string, and now I can use string methods. So I could do .concat hello. But let's not do any chaining yet, because I want you to just see this part first. So you'll see we're still going to get 5 printed back, but now it's 5 as a string, which is evident because I can use string methods on it. So I could do .concat, which I couldn't do before with just this integer. If I try to do I.concat hello, well now we're getting all these errors because concat is not on int. It's not a method on int. Or int's a primitive type, so they don't even have methods. But, right? So that's how this works. That's the value of method, pretty self-explanatory. Now let's jump onto the string.format method. It's the exact same thing as printf. It's the exact same thing as formatted. String.format. So what it does is it'll take in whatever you pass in. So you would, just like everything else, you'd pass in your formatted string. Formatted string, comma, your list of bars. Like this, right? So that's the string.format. So you can go here, I can run, and let's just show all of them. So I could do system.out.printf, and let's not even do that. Let's use the keybind soof, say hello there, /s for name, and I'll write sid. I could do print out hello there dot formatted with sid, and then lastly I could do system out string dot format hello there like this, and passing sid. You'll see we get the exact same thing every time. They do the exact same thing. Oh, one thing I did forget. Remember that this printf doesn't auto make a new line, so you have to run this. The reason why these are making new lines is because we're printing them out with print line. So if you just run this, yeah, boom, boom, boom. And I guess just for purposes of this example, I can make these all print. And I could add a slash %n to all of them. And then I could run this, and then you would get this. Same thing, okay? That is the string.format method. We're so close to the end. Ooh, this is a really important one that I want y'all to know. So it's gonna be string.join. So this kind of dives into the concept of arrays, but it's okay, because I want y'all to know this. String.join. What does this do? So first you pass in your delimiter. So if you remember back when we were talking about split, and that you'd pass in a delimiter to split, and that's how it split things by, right? Well, this is kind of similar in a way, where it's like the opposite. It'll combine things together. So pass in your delimiter, and then you can pass in some iterable, some like array, some list type, some collection type, whatever. You can pass anything here, even a string. and it'll combine the elements with this delimiter. So I don't think this example does enough justice on how valuable this is. Let's say I had an int array. Yeah, let's do int. I just want to see what happens. Int array, and we'll set it to 1, 2, 3, 4, 5. Well, let's print out string dot join. Let's say comma, or let's do like this. And I'll pass in the int array. We might be getting an error because it's a yes. I just want to double check. So you need to pass in a character sequence or string array. You can't pass an integer array in here. But we could just, nevertheless, we could do something like this, I guess. Now just call this R for simplicity. Well, you'll see when we run this, we're going to get 1 with delimiter, 2 delimiter, 3 delimiter, 4 delimiter, and 5. Because this works like, if you think about how split things by some delimiter. So it's split with split an array by the delimiter. Join joins an array by the delimiter. That's probably not how you spell delimiter. I like this. Okay, so you see we got 1, and then it was joined with this double exclamation. Then that was connected to 2, which was joined with this double exclamation. Then 3, then 4, and then 5. Now, no, it doesn't. It didn't start off with the double exclamation. It added it onto this in order to end with a double exclamation. And just to prove it, you can use a string. I'll pass in a string hello, and then we'll run this. And then wait, am I tweaking, bro? HEL. Oh, sorry. It should be like this. And then when I run this, there we go. Boom, boom, boom. Now I might be asking Sid, why didn't I see anything there? Well, if we just talked about in that previous example, how what 1, 2, 3, 4, 5 join won't join the array. So we talked about, sorry, I was getting call. Join won't start with the delimiter nor end with it, right? So when we had 1, 2, 3, 4, 5, it looked like this: 2, 3, 4, 5, and nothing here, nothing at the start, right? Well, when I passed in, the reason we're seeing this result is when I passed in hello, Java looked at this as an array containing one element. And while it can't start, it couldn't put something here and then did like this, because it won't start or end with this limiter. That's why we got hello back. So you can either pass in an array like this, which is what you saw me do, or you can use join like this, where just pass in multiple characters. So A, B, why am I getting an error? Required type, oh, I'm sorry, I think they need to be, they need to be strings, sorry. A, B, C, and now you'll see when we run this, A, B, C will be connected like this. There's the two ways you can pass it in. You can pass in a data type like this, like an array, or you can just pass in the elements individually, separated by commas. So the last method we need to talk about is the copy value of method. So copy value of. And the unique thing about this one is it only really works with character sequences. So you have one form where you pass in the character index, and it'll take that character index and turn it into a string. I mean, you can do this with value of too. The second form though, you can't do it value of, which is why I really want to bring it up in the first place. So you'll pass in your character array. You'll pass in an int for your starting index. And you'll pass in an int for the size of your array. Or for the length of your, here is probably better. For the length of your string. So how the way this would work is if I took a string, like a character sequence that was made of like like this. A, B, C, that's no even near C. C, D, E, F. And then so let's say start at index 1, length of tree. Well, let's start at index 1 and contain B, C, D. It give out a string of B, C, D because that string would have a length of tree. Okay, and you can test this in code. I really have the exact setup right now. You could run this, you see we get B, C, D. If I maybe made the offset 2, well, then I'd start at 0, 1, 2, and then have a length of tree. So it'd be C, D, E. As you can see, we get C, D, E. And that concludes string methods in Java. So there's a lot we went over, a lot in this video. This video is probably going to be my longest one, roughly like 2 hours I think it's going to be. But string methods are important. And they can really throw any one of these at you, bro. Like, I was not expecting to see the dot intern method show up on this test, bro. That's crazy work. I don't know, the test makers are scheming up this year, bro, but yeah, just make sure you know these methods. Alright, thank you for watching. Goodbye now.